It is Jono from Seneca, and today we are getting intimate. We are talking about the forces between molecules. What do we call those? Intermolecular forces. I'm going to be running through the different types that you need to know for your A-level chemistry exam. Let's dive in. What are intermolecular forces? They are forces that operate between all types of molecules, and they are much weaker than intramolecular forces. Remember, intramolecular forces are bonds. Check out the earlier episodes on bonding to get up to speed on that if you're feeling a little bit confused. And now we're going to shift our focus to those intermolecular forces, and we're going to look at three types. First, we have induced dipole-dipole interactions, and those are the weakest ones we're going to consider. Then we have permanent dipole-dipole interactions, and these are stronger than induced dipole-dipole interactions, but weaker than hydrogen bonds. And then we've got hydrogen bonds. These are the strongest form of intermolecular force that we're going to consider, but they are still much weaker than intramolecular forces, like covalent bonds. Honey, you don't mess with a covalent bond. That is strong. So what is the order from most to least strong intermolecular force? We start with hydrogen bonds, then we go to permanent dipole-dipole interactions, and then we go to induced dipole-dipole interactions. What about a covalent bond? Well, that's a plot twist, honey, because that is not an intermolecular force. A covalent bond is an intramolecular force. Now, let's start with induced dipole-dipole interactions. These are also known as van der Waals forces or London dispersion forces, and they are formed from temporary dipoles. The word dipole is like striking fear into your soul. Make sure you check out the episode on polarity where we break down what a dipole is and how they form and what electronegativity is. So make sure you get up to speed. Now, temporary dipoles. The electron clouds around a molecule are constantly in motion. One moment, all the electron density can be on one side of the molecule, and the next, it could be somewhere totally different. This is called a temporary dipole. They are partial charges, but they change very rapidly. If one molecule has a temporary dipole, its partial charge will exert a force on nearby molecules. The partial charge of one molecule can push away the electrons in another or attract them towards it. This means that temporary dipoles will induce dipoles in nearby molecules. Once a dipole has been induced, it will be attracted to the initial dipole. This is called an induced dipole or a van der Waals force. So that interaction is between two induced dipoles. Van der Waals forces are not all the same strength. The strength depends on the number of electrons in a molecule. Molecules with loads of electrons will have much stronger van der Waals forces. And this is because they will have larger fluctuations in electron density, and this leads to larger temporary dipoles and stronger dipole-to-dipole interactions. Okay? So, remember, humor me, what are the three intermolecular forces from strongest to weakest? We start with hydrogen bonds, then we go to permanent dipole-dipole interactions, and then we go into induced dipole-dipole interactions. So next we're going to be talking about permanent dipoles. Permanent dipole interactions exist between two permanently polar molecules. Permanently polar molecules have a delta negative on one side and a delta positive on the other. The delta positive of one molecule will attract the delta negative of another. This means that the molecule will line up throughout a liquid or solid in this fashion. Permanent dipole-dipole forces are the second strongest molecular interaction, and they're between polar molecules because polar molecules have permanent dipoles. So example would be something like HCl. Now, so let's recap that. A permanent dipole in a molecule creates a partial positive charge and a negative charge across the molecule. These partial charges will attract the partial charge in the other molecule, and this attraction is a permanent dipole-dipole interaction. Now, what is the strongest type of intermolecular force? Well, if you've been listening, it's a hydrogen bond. Hydrogen bonds only exist between some specific types of molecules. These intermolecular forces are stronger than induced and permanent dipole-dipole interactions. Hydrogen bonds. A hydrogen bond is the name given to a very strong permanent dipole-dipole force. With some elements, hydrogen can form extremely strong dipole-to-dipole interactions. When these are strong enough to be considered a bond, it's called a hydrogen bond. Hydrogen bonds are found when you have a hydrogen atom bonded to either oxygen, nitrogen, or fluorine. That is, oxygen, nitrogen, or fluorine. the hydrogen atom will form a strong permanent dipole-dipole interaction with another oxygen, nitrogen, or fluorine atom. Examples of liquids with hydrogen bonds are water, hydrogen fluoride, and ammonia. Why do hydrogen bonds form? Well, when a hydrogen is bonded to an extremely electronegative element, it develops a strong delta positive charge. Hydrogen is a cute little small atom, so it has a high charge density in this situation. This allows it to form a strong bond with any highly delta negative charged atom. So, hydrogen bonds exist between hydrogen and any which of the following atoms? It's nitrogen, oxygen, or fluorine. NOF, as if you want to remember it. I don't know what NOF means, but nitrogen, oxygen, and fluorine. Hey. The word doesn't mean anything, but like remember the sound. NOF, 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 NOF. So nitrogen, oxygen, fluorine, NOF is the atoms with which we can get hydrogen bonding. Let's jump back to temporary dipoles. Why are they temporary? It's because they have partial charges in the molecule and they change rapidly. Those temporary dipoles are constantly being made and broken. What's the strongest type of intermolecular force? Hydrogen. Remember, it's hydrogen. What's another name for van der Waals forces? Induced dipole-dipole interactions. That's induced dipole-dipole interactions. So what are the key features of induced dipoles to finish? Let's recap. 1, a molecule has a temporary dipole, because remember, electrons are always moving around, and all of the electrons might be on one side of the molecule at one moment in time, creating a temporary dipole. The partial charge that's created exerts a force on nearby molecules. The partial charges on one molecule can push electrons away in the other molecule. This induces the dipole in the other molecule, and the two temporary dipoles can then attract each other. Boom! Intermolecular forces, done. Killed, annihilated. Hopefully you feel confident about them, and make sure you remember the difference between inter and intramolecular forces. Don't fall into that trap. And there's only 3 you need to learn: induced dipoles, permanent dipoles, and hydrogen bonding. It's not too bad. Thank you for joining me on this episode. I've been Jono from Seneca. Make sure you check out the other episodes in this A-level chemistry series and let me know what you think of them. I'd love some feedback. And thanks for joining. Catch you on the next one.